Right. So day one, huh? Let's start with me explaining what SubD is, right? Because we are going to kind of dive deeper into SubD, and I'll try to kind of convey an idea of what SubD does. So in Rhino 7, you do have the standard tab, the C-planes tab, and all blah, 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 all of that good stuff. But you also have the SubD tools tab, which is the thing that we're going to be looking into today. Tomorrow we're going, or not tomorrow, day after tomorrow, we are going to be looking into Grasshopper, part of SubD, and some mesh tools, but today is going to be just SubD. So as I said before, I believe yesterday, SubD is short for subdivision-based model. And the way it works, it's, think of it this way. So up until now, you know two types of geometries. There are meshes, right? And there are polysurfaces or NURBS surfaces, right? So the difference between meshes and NURBS surfaces are that meshes are made out of points, which are called vertices. And I'll just kind of, just to illustrate the idea, I'll just kind of draw some random number of points, doesn't matter, right? So meshes are made out of points, and those points are joined with edges, right? And those, basically in between those edges, you have faces, right? Or what's called polygons, right? So that this is basically, well, it's not a mesh, but this is a representation of a mesh, right? You have vertices, you have edges, you have faces. A mesh can have either a triangular face or a rectilinear face, like so 3 or 4 points. So you either call it a tri-mesh or a quad mesh, or it can be a mixture, just like here, right? So meshes are the most universal and most used format for storing geometric information, because all you need to have to store this information is basically two lists. One list consists of, let me write down text. Just real quickly, there we go. So one list consists of points, oops, and their coordinates, right? So here I have 1, 2, 3, 4, 5, 6. I have 6 points for this particular mesh, right? So I would have like a list of points, and I would say point 1 is the coordinates for point 1, x, y, z, are, let's say 50, 50, 10. I don't know. Coordinates for point 2 are 25, 25, 11. You know, so basically you just describe where the point is, where each of the point of the mesh is positioned in the world, right? According to x, y, z coordinates. And you do that for every point, right? So that's the first list of the mesh. The second list is basically faces, right? So you have a list here of 6 points, and they all have their numbers. They're numbered. So the second list would be faces, and it would say face 1 is created between let's say 0.5, 0.0, and or 0.5, 0.3, and 0.8, right? That's phase 1. Phase 2 is created between 0.5, 0.9, and 0.11. Doesn't matter, right? So you are describing the position of the points, and then you're describing in between which points are you creating surfaces, and that's it. That is all that you need to create any geometry, right? Any mesh geometry. So this is by far, a mesh is the most lightweight way of saving things and the fastest, right? Then you have NURBS, NURBS geometry, right? So NURBS geometry is basically, I can kind of, let me try and show you this way. So we have one curve, we have another curve, and we loft them together, right? So that's a NURBS surface. The way NURBS surface is described is much more complex. And the reason for that is it uses NURBS curves as its foundation blocks, right? So it's created not from points and their coordinates, but rather from curves. And all of these NURBS curves are described with what you really liked in high school. F to x equals sine x plus 11, blah, 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 right? A function, right? And that function is basically describing exactly this curve in exactly these, this location, right? So you can assume that the function, right, is super long, right, to be able to describe this curve. And also it needs to describe two of them, right, two of these curves. So you have actually two functions, right? And then you have a third one also, which describes the area between these two curves, right? And that last function is indeed the surface. It generates the surface. So it's basically a mathematical formula. Like a NURBS surface is a mathematical formula that is infinite in resolution, right? Because it's just a mathematical function. So it doesn't have resolution. It's just perfect, right? But it requires a lot of much more computation power, and it's much harder to store it. While meshes are much easier to store, but they have a limited resolution, right? So if I were to zoom into the surface, I wouldn't start seeing polygons or pixels, right? It would always be the same. For mesh, if I zoom in, this is like the largest, the biggest close-up that I can get to. If I zoom in even closer, I get nothing, right, from it. So that is a very important difference. So now Rhino 7 comes out, and Rhino 7 says, yo, we can have third one, right? And actually, yeah, go ahead. Wait, it's very quiet for me. Say again. Limitations as in modeling. Yeah, there's like plenty of limitations. So for instance, if you do something like, come on, just a second, there we go. Something like this, and you want to create a surface through it, and you say planar SRF, it's just going to create just a surface here, right? It will not understand, this area. So there are like these logic-based limitations, but in terms of what can be drawn with a NURBS curve, there's not really a limitation there, at least to my knowledge, right? Because everything, any geometry can be described with a mathematical function. It just matters how long the function is, right? Or equation, I guess. Makes sense? Good? Okay, good. So, SubD. SubD was around for quite a while now. I believe it was first introduced into Maya by Autodesk, and then it kind of moved into Blender, and now it's part of Rhino. And together with SubD, there were quite a few additional tools that came in that are quite interesting in Rhino 7, and we are going to be touching on them. But for now, I'm just kind of going to explain what SubD is. So basically, SubD is a third form of how you can describe geometry, and it's a mixture between a NURBS surface and a mesh, right? So when working with SubD, and for this I need to go into a 3D view. When working with SubD, you need to assume that any low resolution geometry that you have, and by low resolution I mean amount of faces, amount of surfaces that you have, is going to be divided up or subdivided infinitely, right? Very, very hard to explain, but I will actually load up Grasshopper. You don't need to, but I'll load up Grasshopper just to visually explain what subdivisions do, right? And how they actually work. That should kind of help us out. Come on, Grasshopper, please. Now that's the first problem that we have is my computer not liking the recording the Zoom call and also me loading in Rhino and Grasshopper. So what I'm going to show you is going to be this kind of a very quick and very, it's going to be a mesh-based subdivision, right? So if I have any kind of a mesh, actually, let's use this one. Might as well, right? Because I already have created it. So I will just take all of this and I'll show you how I would create a mesh from this. I would just simply go to Mesh Tools, and here we have Face, Single Mesh Face, and I would just kind of click, Enter. There we go. That's the first face. Enter to repeat, or yeah, sure. Like that, click. Second phase. So it's manual, right? Creating mesh from points. In this case, I'm doing it manually, but that doesn't matter. Now I join everything up, I move it away, and I have a mesh here. And you can see some parts, some edges here are more bold and the others are thinner, right? I will get to that in just a second. That means that this point right here is duplicated. I will just really quickly do that and also do that. And now it's fixed. We'll talk about that in just a second. But basically this is a mesh, right? Created from points, and I can kind of mess around with it and I can push and pull on these points. But the main thing is if I reference in the mesh into Grasshopper, set one mesh, hide it in Rhino. Now it lives in Grasshopper and has this kind of spiky boy sticking out. If I were to subdivide it, right? And for instance, a tool that does that is called Viewerbird's Catmull-Clark subdivision. If I were to subdivide it like that, you can see that this is the original mesh, right? And this is the subdivided one. And let me just quickly, let's look at it from the top view for now, right? That was the original mesh, and this is the subdivided one. So if I come on, hide that, just so that we can see both of them. If I take a look at this, what happened here was my every triangle received, let me draw out a triangle. I'm just drawing out this guy right here, this triangle right here. Every triangle got a middle point right here, right? The middle point. And then from that middle point of that triangle, 3 edges were created, right? Like that, and like that, right? So 3 edges were created. So that's for every triangle. For every rectangle, also middle point, also edge, right? So also 3 edges were, or 4 edges were created. So initially what happened was every polygon, every triangular polygon became 3. and every square or rectangular polygon became 4 polygons, right? So it received one level of subdivision. I can do that again. I will zoom into this particular guy right here, and I will subdivide it to level 2, right? So now it's like to the power of 4, I believe. No, not, it's just multiplied by 4, right? And then I can subdivide it to 3. And the more I subdivide it, the closer it gets to being a blob rather than a spiky boy, right? Can show here. The more blobby it becomes. And the reason for that is when we go from level 0, which is no subdivision, to level 1, the vertices or the points of the mesh are being moved closer to the averages of the vertices that are surrounding those points. So what I'm saying, every time when I say points are being moved to the average, think of smoothed. Things are getting smoothed, right? Because smoothing things is literally moving everything to an average. If we were to smooth things infinitely, we would always get a sphere, right? From any form would become a sphere. In this case, we are not smoothing things infinitely. It's just kind of getting an average. Localized average. I will not go too deep into this. I know that this is already a little bit too much. But just understand it this way. We have a low resolution mesh, and then we subdivide it and subdivide it and subdivide it, and with every subdivision it becomes smoother and smoother, right? But it is still a mesh here. Coming back to NURBS, coming back to SubD tools, that subdivision, this number right here that I keep increasing, and when I increase, this gets smoother and smoother. This number right here is infinity, right? It subdivides it infinite amount of times, so it becomes perfectly smooth, right? That is the difference between mesh, a subdivided mesh, and a SubD geometry. And also it's why SubD geometry can be converted into a NURBS polysurface, into NURBS geometry. And also it can be converted into a mesh. So it's like a hybrid between the two. And that's exactly why I want to teach you how to use it. It's super flexible. So that's about it in terms of SubD. And in terms of data types or geometry types in Rhino. Really quickly, if we go to SubD tools, so now you can kind of follow along. Let's start creating stuff, right? So in SubD tools, go ahead, yeah. Mm-hmm. What do you mean by a basic one? Mm-hmm. Oh yeah, that's just like two nodes or two tools that I just dragged in. Actually, we are going to be using that. Well, not that, but I will be teaching you that tool later down the line. Actually, during week number 2 of our workshop. Right now, the reason why I went so fast, in terms of grabbing it and just creating it, just to visually show you stuff on the screen rather than teaching you how to do it in Grasshopper. But yeah, that is a super basic one. It's not even a script, it's just a single tool. Right, so creating stuff with SubD. So here you have all of the tools that are available for you. Eventually you'll learn the commands and you will not be using the tools. Honestly, after the card that I showed you last time, that took me 32 hours, something like that, to do. And I didn't learn the commands, all of the commands in 32 hours. So it, for some reason, I don't know, maybe it's just me, but muscle memory is not kicking in that well with SubD. I don't know why. Either way. If we go from left to right, we will skip over the inset SubD edges, because that is a new one, and we don't, or not a new one, but it's rather a way of how to change geometry, but not a way of how to create geometry. Rather, we will start with create SubD plane. This guy right here. Create SubD plane. And it's basically, the plane is going to be drawn like a rectangle, right? So it's always read what it asks you in the command line, first corner of the rectangle, and also it kind of gives you possible options. So for now, let's just quickly draw it, right? Click, click. Quickly draw it and just take a look at it, right? What it does, right? Once you drew it, you will see something like this. A basically filleted surface. It's not a surface, it's a SubD, right? Which means that if I now hit the tab button, tab, it will go from being filleted to being not filleted, non-filleted, right? So it's going, tab toggles between soft and or how is it called? Smooth and flat display modes, right? So this is flat, and this display mode is flat, and this is something that I use when I'm modeling, while I'm modeling. And tab, when I hit tab, it goes to a smooth version, and the smooth version is what I'm trying to achieve, me checking what I'm trying to achieve. So all of my extruding, lofting, and so on, all of the tools that I'm going to use, I will be using them on a flat, on a low resolution, let's say, model, and then hitting the tab key to check what kind of effect I get, or does it work, does it smooth out the way I want it to, right? So that is, tab is the toggle and the most important one. Hope it works for everyone. Alternatively, I believe there is like a button somewhere here that you can press. Yeah, there we go. So toggle SubD display, this button right here. You can also press it and it's gonna do the same thing, but I think tab key is a little bit more convenient. Okay, coming back to plane, I'll delete the original one. I'll start creating a new one. So SubD plane, and I'll kind of explain what these parameters do. So 3 points are, well, that's the same thing as drawing a rectangle, right? You can either draw a rectangle between opposing corners, or you can draw a rectangle giving it 3 points, the starting, the point for the length, and the point for the width, right? Vertical means just that. It's, well, if I turn on vertical, it's just going to draw a vertical plane, vertical wall. Center, so it's going to draw, if I press center, it's going to draw from a center point. That's sometimes useful. Around curve, that is not something that, yeah, first we need a curve. I wonder if, actually, let me test it out. I wonder if this is going to work. If I have this kind of curve and I go for the plane around curve, select curve. Yeah, that works, right? So really quickly to explain what I'm doing, if I have a curve drawn, right, and I create a plane and it says around curve, it's basically going to create that plane 90 degrees or perpendicular to a given point on a curve. So if I select around curve, then I select the curve, then it's going to ask me to give it a center for the plane. So let's say I give it here, and I draw out the plane. So it's going to be 90 degrees to the curve. And I can kind of repeat it just to give you an understanding of what it does. Like that. And repeat it once more. Like that. Right? So it's always creating these surfaces 90 degrees to a curve. Sometimes useful, most of the time not really. I don't think I've ever used it. I'm gonna get rid of it. Last thing, and a very important thing for plane, is the x count and the y count, right? If I change x count to 1 and y count to 1 and just create a rectangle like so, you can see there's no cross anymore here. I had this kind of a cross, so there's no initial subdivisions, no initial faces. It's just a single face. If I hit tab, it becomes a blob, straight up blob, right? But alternatively, if I create a plane and I give it 10, x count 10, y count 10, and draw it out, it's going to have this amount of subdivisions, right? Or saying subdivisions is weird because it's not really that. It's just amount of faces, 10 by 10, right? So that means we're dealing with 100 faces. And now if I hit tab, you can see that only these corners are filleting, right? The reason for that is that this edge and this point right here is holding the line, so to say, right? It's holding the line. Here, it doesn't have any edges to hold the line, so it's kind of becoming a blob, while here it's staying quite locked in, right? And this is going to be this understanding of edges being close to one another, holding the form, and edges being far away from one another, being able to smooth out more or becoming more blobby, is going to be a very important thing throughout this whole workshop. Okay, so that's planes. Planes are okay. SubD cone, right? I will not be kind of explaining all of these tools in depth because I don't think it's super necessary, but SubD cone draws like a cone, right? Bam, we have a cone. That's without smooth display, that's with. Then we have truncated cone. That's the same thing as a cone, only that you kind of give it the top radius as well, right? Looks super weird. Also keep in mind that if you're creating the cone, if you're creating the cone or any kind of geometry in Rhino, SubD geometry, it's always going to ask you for resolution, you know, for how many faces you want in usually 2 or 3 directions. So here I can say vertical faces. Actually, I just want 1. Or, okay, fine. It asks me to give it 2. So actually, I just want 2 vertical faces for my next cone. And I'm just going to draw it out here. Like that. And you can see the difference, right? So this is with 8, this is with 2, and 8 is 8 subdivisions or 8 faces vertically holds the form much better than 2. Sometimes you want that, sometimes you don't, right? It's absolutely up to you what you want to do with your design. So that's cones. Cylinder, sometimes useful. Straight up, you know, creating a cylinder. Form. If I were to say around faces 3, and then try to create a cylinder, then it's gonna look like a piece of pie, right? But if I hit tab, it's actually smoothing out quite nicely because 3 polygons, right? Or 3 faces. I will use polygons and faces interchangeably throughout this workshop because I never learned the difference. So 3 faces don't hold form that well. So they are smoothed out quite a bit by the tab key, right? So it kind of comes back to being a cylinder, cylindrical. Sphere, well, yeah, go ahead. Absolutely. There's 2 ways of how to do. I will show you both of them, but yes, I will show you how to do that. Not right now though. Sphere. Well, you know, sphere is sphere. Actually, looks pretty sweet when you don't look at the smooth version of it. Then we have ellipsoid, which is basically just a squished sphere. I will not be showing you that, and a torus, which is a donut. Torus is always fun to do, so I'll do it. Right. Quite a fun little thing. I'll show you later. Not necessarily individual surfaces, but you can also do edges, or you can do points as well. And you can kind of work with this as if it's clay, and also you can kind of scale things down and make them creasy, not greasy, creasy, and so on. And it's really useful for flattening things out, right? Making sure that things are flat like that, right? So this is now a flat surface. Anyway, but I will be showing you that that later. It's going to be a part of the tutorials. Then we have SubD loft and SubD multipipe and all of that good stuff. Before our first break, I will show you SubD multipipe because I think it's quite it's a lifesaver in many cases. Because before, let me show you this as an example. If I were to, let's do it this way. Let's create a box. Starting at 0 and just, I don't know, 10 by 10 by 10, right? Just a cube, not a SubD box, just a regular old cube. Do that. I'll give you 5 more seconds. 10 by 10 by 10. Actually, it doesn't matter where you place it, where you have it, as long as it's kind of in the ballpark of my measurements. So once you have the cube, you can select it and you can type in wireframe. Or, no, not wireframe. The other one, silhouette. 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 You hit enter. You type it correctly first of all, and then you hit enter. And it's going to basically generate a bunch of curves for you. For every edge of your box, it's going to kind of create a curve or extract a curve, right? So once you have that done, you can unselect everything and just select the box and just get rid of it. Delete. So you end up with something like this. Curves, curves, curves. Separated curves. I'm just kind of making sure that everyone is on the same page. 5 more seconds and then we'll continue. Silhouette is the command. So once you've done that, just grab a line tool or polyline tool, doesn't matter, and just create some diagonal curves, something like this. Can be something like that and like that, doesn't matter. I just drew like 3 more diagonal curves randomly without thinking about it too much. So you have this kind of geometry, right? And you want to print 3D print this out, right? So what do you do, right? Back in the day, we had to do, we had to select all of this, type in pipe, right? Give pipe radius of, I don't know, 5, maybe? Oh, not 0.5, I meant 0.5. Pipe radius 0.5. Something like that, right? Let me actually drag away the curves from the pipes. And we kind of get this geometry, right? Also, when you're doing pipe, you can kind of say that you want rounded caps or you want flat caps. In this case, it's flat caps. It really doesn't matter. It's going to be crappy either way. And then you would, to make it into one single poly surface, you would start using Boolean union. And you know how Boolean union works from your Rhino course. Basically, if you select everything and type in Boolean union, it's a good chance that it's going to work, but it's also a good chance that it's just not going to work. In this case, yeah, in this case works, right? So that's great. So you end up with this kind of geometry, right? Which you had to sacrifice a little bit of from the corners, but you could kind of rebuild it, and you end up with this type of a thing. In other cases, since we are dealing with boxes, with a box, Boolean union does work, and I kind of wanted it to work for this particular example. That's why I chose a box. But if it's something much more complex, and it's piped and you want to Boolean union everything together, usually it doesn't work. So then you need to do a lot of 3D modeling to make it all kind of connect and become 3D printable. So which brings us to Multipipe now. If I select all of this and I go to SubD tools and I choose Multipipe, which is this tool right here, or you can type in SubD Multipipe, that work, or is it just Multipipe? I think it's just, yeah. If you straight up just type in Multipipe, hit enter. And pipe radius, I believe we use 0.5, right? Cap ends off. And straight divisions, we will just use 1 for now. We end up getting something like this as our output. Immediately 3D printable and always works, always connects properly all of the curves. Right? You can, by the way, I assume some of you are thinking, well, but it's blobby now, right? What if I want it to be sharp? You can always make it sharper by, oh, that's a nice break right there. Nice twisty motion, but it does work, so we don't care. You can make it sharper by introducing creases and introducing more resolution. Let's try Multipipe, pipe radius 0.5, cap ends off, straight divisions, I'll try 10, something like that. That one curve. Why is this curve? This curve doesn't want me to show a decent example. It just. It's just a rebel. This one and this one. These two are just rebels that don't let me show how good the program is. Of course, there's always going to be an issue. But so more resolution equals sharper creases, sharper corners. And you can even increase the sharpness by creasing this. And yeah, as I mentioned before, I'll show it later. So that is Multipipe. Questions about this? Or any questions in general so far? All right, coffee time then. Let's do 5 minutes and then we will continue on. Okay, so coffee time. Recording on and let's go. So that's Multipipe. A lot of potential when you want to create lattice structures, and when you want to create like these quite cool lattice structures as well, or 3D printable ones. I'm just deleting that, and now we're going to kind of start diving into tools that are used with modeling, right? With modeling in SubD. So let's say, actually, yeah, let's immediately jump into the dragging of faces around, right? That's the important part. So if I create a SubD box, just a box, right? First corner of the box, doesn't matter where, and I'm just going to say 10 by 10 by 10, right? It basically creates a sphere, right? Unless you have more than one subdivisions, right? I can't stress this enough, right? If I create another box, if I create another box and my X count is, let's say 4, my Y count is 4, and my Z count is 4, like that, 10 by 10 by 10. Oops, that is definitely not 10 by 10 by 10. Let me just scale 1D from this point to this point, 10. There we go. So if I have these two boxes, and then I hit tab, you can see again that, you know, one is more locked to its original shape, while the other one just moves out to a sphere. That's just straight up resolution. Straight up resolution. So when we have this, let's create a box that is that has divisions of 2 by 2 by 2, right? So if I create a box, X count 2, Y count 2, Z count 2, right? And I'll just start drawing it from somewhere close to 0, 0, 0, doesn't matter really where. And I'll just create that kind of cube of, God damn it, why do I keep 10, enter, 10, enter, 10, enter. There we go. I end up with something that's in between a sphere and a box after smoothing it out. To be able to drag around the faces of the box or the edges or the points, I can either turn on this selection filtering here. Selection filter edges, selection filter faces, selection filter vertices. But these don't have keyboard hotkey or a shortcut, which means that anything that doesn't have, everything that has to do something with selection and doesn't have a keyboard hotkey, in my opinion, is unusable. Because every time I want to select edges and I need to click on this icon, is time wasted. So instead of using these, I will just use Control-Shift. So I'll click and hold Control-Shift on my keyboard, and then click on the face, right? Then release, Control-Shift, and then with a gumball, I can just drag it up. For Mac users, it's probably going to be Command-Shift. Command-Shift, click face, or click edge, or click point, right? all work. You can also, you know, click on several. What else can you do with Control Shift? Oh, I will show you one more thing, one more cool thing, but that's going to be a little bit later once we actually have a need for it. Automatic selection of edge loops around the geometry, but that's later. So Control Shift and just using the gumball, you can move things around, right? So for instance, I can select all of these top faces, and I can, holding down the Shift key so that it's scaled down globally, or uniformly, sorry. So that it's scaled down uniformly, I can scale this whole thing down to a pyramid. And there we go, a house. We made our first house in NURBS. Yay. And look how cool it is. You know, traditional, modern, traditional, modern. You know, so we have that done. So okay, I'm just trying to not forget important things. You can scale, rotate, and move things around by using the Control Shift and Control Shift selection. Right? And you can do quite weird stuff as well. For instance, let's say I want, and this is going to be me kind of smoothly transitioning into design, not design suggestions, but how to solve different problems that might appear during your own design. So for instance, these 4 surfaces right here, what if I want all of them to be flat, right? In the same plane, right? What if I want all of these 4 faces to be vertical? Well, I could start messing around with these 2 edges here and trying to kind of push them in and see, you know, how is this flat enough? Is this flat enough? And so on, you know, messing around with this until it feels flat. I could start creating helper geometry, and that's what I usually do. Is if I create, let's say, a box, and the box goes until here, and I grab these 2 edges, and I enter, short for move, enter, and I move them to perpendicular here. Then it kind of, then it is flat. But a much faster way of how to do it, let me just. There we go. A much faster way of how to do it is if you select all 4 of these, and along the x-axis, and by the way, this only works if you want to make them flat along a global axis, x, y, or z. So along x-axis, if I just click on this doodad here, the icon here for scaling, click, and if I type in 0, it's going to scale everything to have 0 length in x on x-axis, meaning that all of these 4 planes become flat. Swear to God, I'm gonna make a barn house now. There we go. Perfect. So that's how you flatten things out. Right? Does that work? At least one person nod so that I know that it works. Yeah, okay, it works. Good. Again, modern barn house, traditional barn house. Going through the tools, continuing through the tools, one of the more important things is how do you add edges, right? How do you add additional faces to the geometry? And for that, I do need to give you a little bit more theory, unfortunately, of how things work and what is considered to be a clean geometry, clean SubD geometry, and what is considered to be not clean. and that will eventually give you problems. So remember where I said that usually in meshes, and meshes and SubD again are quite connected. So in meshes, you either have a triangular face or you have a rectilinear face, right? In SubD, it's the same thing, right? You either have a triangular faces or you have rectilinear faces. Triangular faces tend to be a little bit more obnoxious when it comes down to them working properly. Quad faces, rectangular faces, tend to work most of the time perfectly in SubD. There is third type of polygon, right? So this is a tri, this is a quad, and there's a third type. And the third type is called an n-gon. And it's basically whatever, that, right? A polygon that has more than 4 faces. More than 4 points around it. N-gon, if you kind of look at the name, n suggests, random number of points, some big number of points. So that's an n-gon. If you get n-gons in your model, it's not the end of the world, but it is going to, but whenever you have issues, always check if you have n-gons in your model, right? They tend to work until they don't, right? So I suggest trying not to have them. How do you get n-gons in your model? Well, glad you asked that. If you just look at this model right here, everything is a quad face, right? That's a quad, right? 1, 2, 3, 4. That's a quad, that's a quad. Everything's a quad face, and everything is connected corner to corner. Every polygon or every face is connected corner to corner. There's never a connection that looks This is a shitty representation, but there is never a connection that looks like that, right? It's always connecting. Come on. Doing my best, trying my best to explain it. It's always connecting corner to corner and never corner to edge, right? This is where the importance of topology comes in, right? And the importance of being able to connect things properly. Why don't you connect things like so? Well, that's because your polygon, this guy right here, will need to become an n-gon because suddenly it needs, come on, that, or rather, let me just put a point there. Suddenly it needs one additional point that is located right here, right? So instead of a quad, you end up with a pentagon, which just looks like a quad. And this is, you start noticing how things are kind of going downhill from here, bit by bit. If you have pentagons that look like quads, then they will smooth. You expect it to smooth out one way, in the preview, but it actually will smooth out in a different way. And, it just builds up. So I would suggest always thinking about the connectivity and creating these kind of loops of rectangles, rectangular polygons. I am opening my browser just to show you mesh topology. Of course, it's a data structure, mesh topology geometry. There we go. And let me just find it. So there are, these examples of how to branch out, for instance. If you have two polygons and you need to create this kind of loop, there are examples, like and logical examples of how to stay within the quad topology, the rectangular topology, without sacrificing everything. The only thing that you sacrifice is this little point right here, which has a lot of faces surrounding it. By the way, amount of faces or amount of edges that surround the point are called valence. So point can have a valence of, in this case, this point has valence of 1, 2, 3, 4, 5. So this is valence 5 point, this is valence 4 point, this is valence 3 point, and also a naked one, and so on. So there's a lot of words associated with this, and I don't really want you to. It doesn't matter for me if you learn, what a valence is and so on. But you do need to understand one thing, that things always connect with corners, right? In geometry, that's the only way of how you create both clean meshes and also clean SubD geometry. For NURBS polysurfaces, it's a little bit different, but NURBS polysurfaces have their own issues. So that is how it works. Oh yeah, there we go. Never do this. That's an example of what not to do. Right here, never create that. Okay, let's come back to the geometry, and let me teach you the ways of the topology. SubD tools, I will insert edge, and I have no idea where it is, so I will try to, yeah, there we go. It's this tool right here. It's called insert edge, right? Or you can type in insert edge, that works as well. Insert edge, it will ask me to be able to add an edge to my shape. It will first ask me to select an edge from which I'm going to, you can think of it as offsetting, from which edge am I going to offset the new one, right? It's just a way of how Rhino understands where I want to add it. So it asks me to select edge from loop. So I will select an edge. Let's say this guy right here, this edge right here, and it selects the whole loop for me. I don't really want that. I want to mess it up. So I will not show you a clean version yet. I will just try to give you another. This one also gives me a loop. This is too clean. God damn it. Maybe this. Yeah, there we go. There we go. This edge right here, the bottom one. Once I have selected it, actually it's two edges. Once I have selected them, I hit enter, and now I can position the new edge anywhere, either here on this side of the, of the edge that I've selected, or on the opposite side here in the bottom. So I'll just position it somewhere here, doesn't matter, click. And now I have indeed inserted the two edges, and I indeed have done exactly what I told you not to do, right? We have two polygons here, and they connect to this polygon here without any, into an edge, not into a corner. If I hit tab, you can see that, everything is smoothing out quite nicely. And here it is smoothing out. So don't think that it's immediately going to scream and break and your computer is going to catch on fire. But it is going to kind of look a little bit awkward because this is an n-gon. And eventually it's going to kind of, the more you do, the more it's going to kind of look more and more awkward. So then you start fixing things around, just fixing things and trying to work around this. Let me undo this. And let me add a proper edge loop, right? So I'll do insert edge again. I'll choose type as my loop. So loop is just basically all of the edges that are connected into a chain. Rhino tries to catch that, to understand which edges make up a loop, right? So edge loop, I will try to select this one and it only gives me that. So sure, I will not do that. Yeah, that's a loop at least. By the way, right clicking is same thing as enter, if you don't know that. And enter is same thing as repeating the last command you used. So every time when I cancel and do the command again really, really fast, that's just me hitting escape and right clicking and just kind of switching to the tool. Okay, so I've selected this whole edge loop. I hit enter, and now I can kind of position a new edge loop all throughout the building or the barn. And I will position it really close to the edge here. Something like this, like that, right? And now when I hit tab, you can see how much sharper this gets, right? Compared to this. This is what I call holding edges. Edges that hold the crease, and it's how it works. There's all different ways of how to do it. So this is just one of them. And this is basically insert edge. There's nothing more to it. The more you use it, the more you know how it works. Another one, another way of how to create sharp edges that are really sharp is called crease, right? So I can, holding down the Control-Shift keys, Control-Shift, I'll just select this little guy here, this edge right here. And I can either type in crease or I can click on this little icon right here, add crease. Add crease. So I click on it. It will say added creases to one object. I will unselect. And now I can see that this edge right here for me is shown in a bolder, as a bolder line, right? It's thicker. And when I hit tab, I can see that it's holding the angle, right? So this is not enough for it to hold the full shape because it's just one edge. But if I kind of go through the whole perimeter like that, and then add crease to the whole perimeter and hit tab, then it is indeed holding the perimeter. So this is how you sharpen things out. I personally never use creases. I don't know why. I tend to, if I need to crease something, I tend to do this approach, right? Where I kind of bring in my my edge loop really close to the edge and kind of work with it that way instead of having it as a crease. But that's just, I guess that's just preference. It works both ways. Right. I think we're about, we still have 13 minutes before our little lunch, but one more thing or two more things that I want to show you. One is, how do you visually inspect your geometry? Is it good? Is it bad? How does it look like? So that one is, if you select your shape and you type in EMAP. EMAP stands for environment map. You hit enter. And then you can unselect. This kind of menu will pop up, right? And it's going to show you like it's going to ask you what kind of environment map you want. Would you like to show edges and isocurves? Usually I have them turned on unless I have a very intense model, intense 3D model in terms of how many edges it has. And I have no idea. Blend with object render color. I have no idea what it, well, I do have an idea what this does, but I never use it. So unnecessary for now. The most important part is for the EMAP is using a tool that's called, well, I like to use either fluorescent tube or true sphere, these two maps. Fluorescent tube helps me understand whether or not the n-gons that I have are messing up my curvature, the curvature of my shape, because it's basically, let me give you a little bit of history. So, or not history, just a little bit of information. Fluorescent tubes are used in car industry. They're used when they create a car shell, right? A car body, and they need to see if their manufacturing tolerances are correct and if the curvature of the car is seamless throughout the whole body, right? So they use this fluorescent tube and they go around with, in a dark room, they go around with the fluorescent tube and they look at the reflections and they try to see if the reflections are making any kind of anything like this, right? I just creased this edge just to show you how it works. So if the reflections are doing something like this, people in charge know that, oh, we need to fix this tolerance, right? This is a problematic area, and that means the surface is not there yet in terms of quality. Why we use fluorescent tube is to check whether or not the curvature that we have in our shapes is fine. For instance, it does make a little bit of a hiccup here, but I still think it's okay, right? Like this. Yeah, that seems fine. So the more you use it, the more you know what to look for, right? With fluorescent tube. Another one that I really like using is True Sphere. It's not as sexy as fluorescent tube and not as sexy as the original one, the Arches one, but it does show me kind of globally how things are flowing through my geometry and how things are reflecting along my geometry. So this helps as well understanding. It's also called a zebra pattern analysis. Really helpful. Also can be used on any kind of geometry, by the way. You can do that, and this guy right here is a little bit, let's say -1, like that. Loft, okay, delete, escape or close that window and emap this. So you can analyze any kind of geometry with this and see, you know, how it works. If you just want a pretty, you know, to look at it in a pretty way, you can always do this, right? This is like an environment of some sort of a city, central square in a city. Go ahead. But does emap work? That's weird. But when you use emap, when you select an object and you type in emap, does it change color? Oh, it works. Okay, it's all shiny and pretty, but it doesn't give you a panel, huh? Okay. Well, it actually makes sense. If you were to kind of mess around, like minimize Rhino, maximize Rhino again, and so on, it is an external window, which sometimes doesn't. You need to fish it out. I wonder why it's not showing up. Right. Could it be that it's kind of located on the right hand side and it's super squished in like so? That you only have like the EMAP option super squished where the layers are? Mm-hmm. And it pops up. Okay. So it's just, yeah, it's a little bit finicky. Same thing with Grasshopper, by the way. If you'll ever lose Grasshopper, minimize, maximize. And the Grasshopper window will pop up again. Okay. So Hannah, if you won't get the EMAP to show the EMAP window in 5 minutes, I will we'll do the screen share, and I'll help you. No problem. Okay, so that's how it works. One last thing before we break for lunch. That thing is going to be called inset. If we go to SubD tools, there is this first tool that we had that's called inset SubD edges. And it's basically, you have offset, right? And you all know what offset does at this point. So inset is offset only that it goes inwards, right? So if you select inset SubD edges, or you can just type in inset, doesn't matter. Not insert, inset. Enter. It's going to ask you for faces. So you select, I'll select these four faces. I'll hit enter. And then it's going to ask you, would you like the mode to be group or single? So now let's start with group, like modes, let's set it to group, hit enter again. And now the next thing that it's asking you is the distance, right? Basically, by how much should it inset? And you can already see what it does, right? It takes all of your polygons and it groups them up into one big happy family, and it creates from the perimeter of your selection, it offsets it or insets it inwards, right? So in turn, it's creating more polygons. If I select 0.1, yeah, sure, let's do 0.2 actually. 0.2, a little bit bigger, enter. We have something like this, right? If I hit tab, I can see that now this edge right here is also being a little bit more locked in, right? That's just, whenever you have two edges close to one another, it's going to do that. It's going to kind of make the geometry a bit more crisper. What can you do with this? Well, you can, for instance, select all of these faces, right? And you can now move them in like that, right? Because if I were to show you this in wireframe, and let me undo just so that you can, or sorry, let's do ghosted view instead, a bit better than wireframe. If I now select these four faces that were inset, right? And I move them in a little bit, you can see what happens here, right? So we're creating this kind of a pushed in look. If you want to be a little bit more precise about it, you can by just selecting these faces, and instead of just moving them in, you can extrude. So under SubD tools, yeah, there we go. That's the button, extrude SubD, or you just type in extrude SubD. Extrude SubD, enter. It's going to be super wonky. when you try it, right? That's because the direction is set to be free. So instead of direction being free, we will choose, what's the axis? X axis. So we're extruding it along the X axis, like so. So I changed the direction to X. And now I can extrude it inwards. I can type in the number, by how much do I want to extrude it to be precise. But in this case, I'm not being precise. So I'm just going to kind of click my mouse and just extrude it inwards. And now we have something like this, right? Just extruded it. Hit tab. I have no idea what I'm creating. A burrito, I guess. So we have this going on, right? More extrusions. We have this going on, and then I can, for instance, select these 4 surfaces, and I'm going to show you inset again, but this time I'm going to show you inset without the group option, but with the single option, while still selecting multiple faces, right? What happens then? So if I select these faces, I choose to inset these faces, and mode, I change this to single and hit enter. Now you can see that every face receives like this picture frame inset, right? So every face individually gets an offset. So I can do 0.2. Actually, yeah, sure, whatever. 0.2 works. Hit enter. So we have this kind of effect going on. And then I can, I don't know what I'm doing, move this out like so. Hit tab. Now we have, oh man, now we have something like this. Looks so bad. And if you want to kind of make it more crisp, you can always inset again by 0.01 to make it super small, make the inset super small, and it's going to kind of make this a little bit less blobby, and at least in one direction, right? Right. So up until now, every tool that I've shown you was purposely selected so that we don't mess up the topology, right? Well, maybe insert edge. Insert edge can mess up the topology, but every other tool, extrude and inset, it will always, I mean, if we look at it, and let me undo it a little bit, just so that it's easier to see. That's a quad that connects perfectly. That's a quad that connects perfectly. Where else? That's a quad, and that's a quad. And, everything is kind of connecting into this perfect grid, right? And the topology is super clean. Stuff that I'm going to show you from now on, well, after the lunch break, is going to be stuff that can break your topology. A really quick example would be, I'm not even gonna explain what I'm doing right now, but something like this. You immediately messed up something here, right? And the shading is all screwed up now. If I look at the EMAP with true sphere, please. Okay, let's do fluorescent tube instead. Holy crap, come on. Fluorescent tube, there we go. Actually, fluorescent tube is not that bad. Seems to work. Never mind, it's kind of locked in there. And there's a mistake there. Anyway, sorry. And now I'm in my own head. So stuff that I'm going to show you next is going to be stuff that has the potential to break topology, and you will need to be careful about it. Most of the time, honestly, most of the time that you are going to spend during your design with SubD is going to be cleaning up the geometry, because before you have the understanding of what steps need to be taken to get clean output immediately, before you kind of gather that understanding, you need to make a lot of messed up geometries, to understand what doesn't work, to know what works. But that's a part of the journey. Once you've done this, you will be much more, your tool base is going to be much, much bigger. Before lunch, also, I want to just show you, yesterday you talked about inspiration and what kind of lectures or what kind of books or whatnot I could show you. In terms of SubD geometry, there are quite a few projects out there that are done with it partially. And once you've kind of modeled with SubD, you will be able to notice them and understand them, understand that it has been done with SubD. But two that are most interesting to me, at least. One is called, oh my God, by Mad Architects. Mad Architects, this one, but I'm trying to, God damn it. Of course, I'm blanking on the name. Harbin Opera House. This one right here. Maybe exterior is still, kind of lofty. Let's say it like that. It's a little bit lofty, but the interior is, well, first of all, it's really beautiful. The interior of this building is beautiful. Second of all, this is indeed achieved with SubD geometry, right? You can kind of tell by the way it connects and so on. So these are not renders, by the way. Some students kept asking me, which program did they use to render? Labor. Yeah. That is some insane carpentry right there. CNC milling. It's CNC milled glue laminate. So you mill and you, I don't know if it's steam rolled, if it's placed in steam and like Norwegians do their boats, used to do their boats. I don't think it's done that way. I think it's just straight up CNC milled and then pieces glued together, like layers glued together to make it a little bit more bulky and make it hold. And that's one of the interiors of the opera itself. I mean, you might like or you might dislike the blobbiness of it, but I mean, the effort, you do need to appreciate the effort of this project. And the only way how it's possible to do it is through tools like Rhino, right? So that's one. And the other one is by Subdividing Architects, actually. Well, honestly, 90% of stuff that they do is SubD, but the one that I want to show you is Morpheus Hotel. Even though it's not, it's not as fantastic as other projects, not so much in your face as other Zaha's projects. But the reason why I'm showing you this is because there is a video, a webinar, and it's actually on Vimeo. just give me a second. Vimeo is never fast. Morpheus Hotel Zaha webinar. There we go. 2.5 hours of really skilled people talking about how they what they needed to do to achieve this building and to actually make this building manufacturable, I guess. Let me just skip through this real quick, showing visuals, and it's a webinar, right? So it's just people from Zaha talking, right? So this is the part that is the SubD based geometry. That's what they want, and this is where it becomes kind of technical. Let's say it like that. And this is where they start going like, okay, so steel can't bend that way, so we need to kind of start rationalizing things and figuring out how to clad it, and you know, how to create this kind of detailing, and how to understand, you know, how to make things parallel. That's also a very important thing. So it's 2.5 hours that I think every student should spend listening to people talk about how to realize unreal geometry that seems to be unreasonable. Front is every time when you will have a facade that is impossible, you call front. Then they tell you it's going to be 5 million for initial concept, and you pay them and they will build it. Right? They're top. They're high standard, high grade facade consultants. That's how they worked with it. This is a Rhino 3D model of it, of just one kind of connection with all of the parts. Really quickly, yeah, another cladding system. What kind of stuff do they get from Rhino? That is just a black screen, and this is construction phase, and kind of them just answering. Yeah, this is just them answering questions, but it is a very interesting webinar to listen to. I will link it in the chat. And with that, we will go for lunch. Do you have any questions before we break for lunch that I might answer? No? Okay. That means I'm going too easy on you. That's fine, we'll figure something out. Let's meet up in, oh yeah, recording, there we go. So, for now we have this beautiful shape right here, which has perfect topology. Everything is super clean. And I've showed you how to how you can mess it up by moving some points around and what kind of effects you can get from it, right? So that is one thing. But now I will show you more tools that really will mess up, might mess up the geometry. So I'll delete the house. I don't think we need it. I think it's going a little bit too close to actually looking like a house. Instead, we'll work with cubes and something boring, so that you get bored of the boring stuff, and stuff that you create is going to be interesting. At least that's my hopes. One more thing before we begin. Don't feel like we are imposing style onto you. right? Because SubD has a distinct style of connectivity, right? Everything is kind of, well, disregarding the creases, the part of where you can crease the geometry, most of stuff looks like it's kind of interconnected and everything is kind of flowing from one shape to another, which can be considered either a design direction or maybe even a style. That is not something that we want to push on you, but rather think of it as a tool which you can use in many different ways. So you can make it either flowy or you can make it boxy, right? So you can indeed use just the box tool and create your I want to say crematorium, your naturum, like that. Crematorium was a few years ago. So you can create your naturum by just kind of using the freaking box tool and starting to mess around with it and merging things together, right? Using Boolean union on things. This is fine. Well, this is fine as well. This kind of architecture for this course is fine as well. You don't need to do flowy stuff. One thing though that I want to note is the SubD course deals with advanced modeling techniques and advanced concepts in architecture, or modern concepts in architecture, right? It's kind of in the name, contemporary, right? So if you just want to do a very simple barn house style of a building, ask yourself, why did you join this course in the first place then, right? Because the main premise of the course is to do more kind of out of the box. I don't want to say advanced. It's not that traditional architecture is not advanced. It can be super advanced. Contemporary. Let's say contemporary, right? I strongly encourage you to think about contemporary architecture rather than relying on traditional one within this course. Style, though, doesn't matter. Whatever you want. You can do whatever you want. So coming back here to SubD tools, I will make a box. Just a SubD box. I'll start from 0, enter, and then I'll just give it like 10 by 10 by 10. Right? So I have this kind of a box. Subdivisions 2 by 2 by 2. Right? So we have this box doodad here, and I can for instance select it, holding down the Alt key. I can kind of move it to the side like so. Right? When you hold down the Alt key and you move something with a gumball, it makes a copy of it. So we have two boxes now, right? Hitting tab, both of them smooth out nicely. Right? What if I want to create some sort of a bridge between them? Well, actually, let me do one thing. So I will select the top of this box, Control Shift and click. Select all of the faces here, and I'll type in extrude SubD. And you can see that it extrudes sideways, right? That's one thing that I wanted to note. That's the direction, that's the locked direction that we have to deal with, right? So I need to switch direction to Z, and now it's going to extrude up, and I'll just give it like 5 units. So I'm basically, what I'm doing is I'm kind of giving myself more faces to work with. I'll just delete this one and make a new copy of the big one, right? The same thing, it's just I extruded the top. Oh, it can be, by the way, any proportion you want, right? So doesn't necessarily need to be 5, can be something else. Something else entirely, right? And let's say I want to connect these two boxes, right? I want to connect these two boxes with a bridge. How do I do that? Well, first of all, I need 2 openings. That's the first thing, right? So I need to delete 2 faces, right? One face for the left box, one face for the right box. So again, Control Shift, I select one face on my left box and I just delete it. So basically I make a hole here, an opening. Control Shift Select and hit delete. If I hit Tab now, you can see that there's a hole, right? That is also, by the way, being smoothed. Like that. And same thing here. I'll just select this face here on the right-hand side box, hit delete. I have an opening here as well. So I have 2. One here, one here. Now I want to join them up, right? I want to join up these 2 openings. So there are 2 tools that I will show you. I will do it with 2 different tools. So basically to show you two tools, god damn it, I will select both of these boxes and I'll just make another copy of them to the side like that. Just so that I have 2 pairs, right? And I can show you one tool on one pair and the other tool on the other. So the two tools that we will use, one is called Loft, and you know Loft by now, and the other one is called Bridge. So Loft we're not going to straight up use Loft. We're going to use SubD Loft, which kind of creates a SubD geometry. And we are going to use Bridge, which only works on SubD, at least to my knowledge. Maybe it works on meshes, I'm not sure, but to my knowledge, it only works on SubD geometry. So in terms of lofting, let's do it with this pair. It's located right here, SubD Loft, right? And I will click on it, or I can type in SubD Loft. I'll click, select curves and boundary edge chains in loft order, right? So I can select this edge right here and the corresponding bottom edge of the other box right here. So these 2 edges, and I hit enter, right? And once I hit enter, it creates this circle thing, right? And this is a SubD face. The problem is that it's disconnected from the 2 edges, but by working with these options here, we will be able to make it work, right? We'll make it connect. So if I choose corners to be tick marked, then immediately it kind of connects to the corners properly, and it's like the SubD new SubD face that is created with the loft kind of fits in perfectly. Creases means just simply means that this edge and this edge will become creased, meaning sharp after the loft is done. That is whatever. You can crease it yourselves later on. So I never have this on. Closed. Closed only works if you have at least 3 edges, right? That means it's going to make a loft that is a loop, right? Like a ring. In this case, since we have 2 edges, closed will just break. It won't work, right? Because it needs to go from one edge to the other to create the loft, and then you're saying it to go back. So it just kind of deletes itself. So closed doesn't work in this case, but I will show you how it works in a bit. Adjust shape segments. I have no idea what that means, but we can try. Okay. So if adjust shape segments is turned on, this slider or number rollout will become not grayed out, will become white, and you can increase it. And as you increase it, you can kind of see what's going on, right? So it's adding more edges. You don't want that for sure, because immediately as you're doing that, you're messing up the topology, right, of the shape itself. So you want to have, you know, corner to corner without any additional crap here. But what you can do is divisions between shapes. You can increase this because this doesn't break anything, right? So you can add more polygons in the other direction because it's still corner to corner. Every connection stays corner to corner in this case. But I'll stick to one for now. And join is basically, if this is tick marked, all of these three guys will be joined together. If this is not, they will stay as separate pieces of geometry. So I always have it joined, set to be joined. It okay? We're good. Hit tab. We have a connection. It's not the prettiest, but we do have it. So that is loft. I mean, actually, it's pretty cool. Honestly, we'll make it nicer. For now, I'll Control Z. I will undo because I want to loft two rings together, right? So I want a tube, not just a surface. So SubD loft again. My voice is going. SubD loft again. Select curves and boundary edge chains, right? So I can do, I can just kind of click, 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 and click, like select all of the 4 curves counterclockwise, starting from the bottom one in this loop. And then I can select corresponding curves here. So these are going to go clockwise, like that. So bottom connects to bottom, side connects to side. So you need to kind of keep in mind which curve you selected first, which you selected next, and so on. If I hit enter, it looks super weird now. Let's just YOLO it and see what's gonna happen. Yeah, okay, that seems to, it seems like I messed it up. It seems like I messed up the seam. And you can see that it's showing it smoothed out, and we are kind of in a flat shading view. So it's not the best tool for this kind of work, right? I can still kind of do corners. I can connect it to corners, creases, closed no. I can join it. Well, creases, I'll turn it off. So corners and join, that's exactly the same thing that we had before. I'll hit OK, and this is what we end up with, right? So I messed it up. Here I selected the bottom, and here it's the side. The bottom connects to the side, so I'll need to revisit this. But this is basically what we get, and it's, you know, it is a connection. If I do emap on it, it's fine. I mean, it's not great, but it's not that bad. Right? But it could be much cleaner, right? So let me show you how to do it more cleanly. Loft again. This time around, I'm going to make, like, be super sure that I am selecting everything correctly. Enter, and then, god damn it, not loft, SubD loft. You should see my live streams. It's a constant problem that I keep using loft instead of SubD loft. Always catches me off guard. Okay, so we have that. Select those. We have that. Enter. And once I click enter once, if our loft is going to be a closed tube, it's going to ask me to give it a seam. And you can see here that my seam is messed up, right? This point connects not with this point. I want it to connect with this point, but rather it connects with this point. So everything is kind of like twisted by one segment, right? Because this point connects with this point. What I can do then is I can click and drag that point to here. It's just basically me adjusting the seam. Click and drag it to wherever you want it to be. And now these are much better aligned. And now if I hit enter, corners, join, hit OK. Now this is clean, right? This is much, much cleaner. If I hit tab, I can see how clean it gets. This is how it looks. And with EMAP, we can see that the reflection is much, much smoother now than what it was before. So that's loft. Bridge, another one. Bridge, enter. It's going to ask us to select first set of edges, or I can just go edge loop, but I will just kind of select them manually because I want to be in control. And so I select them, I hit enter. It asks us to select second set of edges. And it just creates a bridge immediately between these. So it's virtually the same thing as loft. The only difference is, how do I show you this? I'm trying to kind of explain. The only difference of bridge versus loft is that bridge automatically finds correct placement of the faces most of the time, right? It sorts through and finds correct placement of these faces most of the time, while with loft you need to adjust the seam much more. Honestly, I always use loft. I rarely use bridge, but it is a tool that can be used, right? Produces exactly the same result. When you're working with SubD geometry, always think of it as it's just series of surfaces, right? It's just series of patches kind of glued together, right, into one shape. So there's nothing hidden. There's nothing like fancy behind it. All you do is you kind of just, you have a plane, right? Or, well, maybe you have a plane that's 1 by 1. And you don't need to do this, by the way. But, and you kind of just copy it like that, let's say. Then you have, you take those two planes, take them, rotate them, move them to here. So now we have like an L shape. Then you can take this whole thing. Oops. Take this whole thing. Let's see, rotate it like so. Come on. Rotate it like so, move it from corner to corner. So now we have like a tube. You can then select all of it, join it up, and all of these objects become a single SubD. If I hit tab, now I have my form, right? So it's always a bunch of planes or a bunch of faces connected to one another, right? So it's never anything fancy. Any questions so far? Just making sure that I'm not rushing through this too much. Let me, there we go. Order doesn't really, order matters, but in this case, it feels like what matters more is one step after picking the lines. So if I do SubD loft, also make sure that you're doing SubD loft, not just loft. Can't write. There we go, SubD loft. So I go bottom, right, top, left. And then here I start from the corresponding edge from which I started. So it's going to be bottom. And then I clicked on this one. That means that here I'm going to click on this one, then top, and then here, right? So it's basically me saying that this should be lofted with this should be lofted with this, the top should be lofted with this, right? It kind of remembers. I hit enter, and this is the important part. This is the part where it actually tells you where the seam is going to be, and you can see that it's messing up here. Well, you can't see it with this view, but if I hit tab, now you can see it exactly where the seam is going to be positioned. And I can see that this corner right here is going to be connected to this corner, which means that it's going to be twisted, because this corner right here should be connected to this one, right? Let me somehow position it properly. There we go. This corner right here should be connected to this one right here rather than that one, right? So it's like one segment twisted. So what I do, I can either kind of move this one by one segment, or I can move this one by one segment. That doesn't matter which one. But I just click on the point and I drag it, click and drag to the corner where I want it to be placed. Also, there is one more thing, and it's this arrow right here. So this arrow shows the direction towards which it's going to kind of create these surfaces. If I have one arrow looking, to the front and the other one looking towards me like that, trying to flip it around. Come on. Why doesn't this flip around? The other one flips so easy. Hello? Flip. Ah, there we go. Yeah. It's a little bit finicky. You need to kind of move your mouse around the area to see where the arrow kind of flips, and then you just click. So if I have this kind of situation, arrow sticking away from me and towards me, and I hit enter, then it's kind of messed up like that, right? I actually want to see. Yeah, that's not good. So that's the first. Yep, that's the first breaking of the geometry. Yep. So it's the arrows. Make sure that the arrows are looking in the same direction. Right. What else? Adding creases. I already showed you this. By the way, if you want to select a loop of edges, let's say, well, first let's create a loop of edges. Let's create a loop right here. So I will insert edge. I'll use insert edge, and I'll just select, let's say, these 4 edges right here, like that. Hit enter, and now I can kind of insert an edge loop to my bridge, right? So even if during loft you forgot to add, if you did a loft that doesn't have any additional subdivisions, additional like polygons along its length, and later down the line you kind of want to add, you can always insert edge. You just select the perimeter and you insert edge, and you then, bam, you have the loop like that. And once you have created a loop, a chain of lines that are connected topologically into a ring, then you can, holding down Ctrl-Shift, you can double click on one of those lines, and it's going to select the whole loop for you. So again, Ctrl-Shift, click, click, selects the whole loop. And then you can insert edge again, add more if you want to, right? So you end up having this. What else? So we have like inserted these edges here. We can kind of continue messing around with this, so deleting that. So you have an opening there, and maybe that opening is getting super wide on both sides. So I'm doing Control Shift to widen it up. Sorry, not to widen it up, but to connect it. So we have an opening like that, something like this. And maybe this extrude SubD direction Y. This goes out like that. Same thing for this one. Extrude SubD Y direction goes out like that. And this one, we want it to be kind of parallel to these facades. So I'll just scale it to 0 along the Y-axis so that it's kind of flat. So you can see that like all of the design movements that I'm doing, all of them are super simple. They're a composition of super simple movements, right? And the more you do, the more complex the geometry becomes, right? That is basically the way this whole thing works. And adding thickness and whatnot to your forms, to your shapes, is going to be secondary. You can always do this thing. You select the shape and you type in offset SubD. Offset SubD. You choose solid to be turned on, and you give it a distance of whatever the thickness is. I will do like 0.5. Distance 0.5. Hit enter. Delete. So this is the offsetted version of it. And that's, you know, a thickened version of it. It's fine, you know, it could be better, but offset SubD works. I will cover that a little bit later. Right now, I don't feel like there's a need for it just yet. Right, now I'm just gonna mess around a bit. Oh, by the way, you can also do, for instance, you know, you have this box and you want to connect this obnoxious monstrosity to this box right here. You can do that manually by just selecting the points. Make sure that vertex snapping is turned on. It's right in the, wait. It's right here, right in the bottom, where the object snap, O snap turned on, and then vertex snap turned on. And then you can move, select the point, move, enter, and just move it to wherever you want it to be located. And do that for every point. It's not that, I mean, not that hard. There we go. Once you've done that, all you need to do now is just select the two shapes and type in join. It's going to ask you, would you like to smooth the connection? Yeah, sure. You would like to smooth the connection. You hit enter, you're done. Now we have like, I don't know what it is, but something weird. Let me open up the roof of it. Oh, come on. Delete. Beautiful. Right. So you can do that. You can also kind of start then thinking about additional, not levels, I don't want to say levels, but additional complexity, I guess, three-dimensional complexity of what can be, you know, if you had a second floor, how would that second floor look like? But first, let me just scale this down so that it's a little bit more like a building. So if you know, this is your first floor, and then you have a second floor, how would the second floor connect? So you can start kind of creating these single SubD faces. I really like this tool, by the way, single SubD face. It's here in the top in the menu, which basically just asks you for points. And I just kind of click, 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 and start connecting. Start connecting the geometry with my own kind of SubD faces. That and figuring things out kind of manually, right? This is the most manual work ever. Joining everything together into a smooth surface, hitting tab, and now having some sort of a bridge system that I can work with, right? Then maybe selecting the whole, like Control Shift, double clicking, selecting the whole perimeter and extruding the surfaces upwards. So direction is Z. Something like that. Right? Maybe a little bit higher. And then just having the same SubD, those same SubD faces, and figuring out a way of how to kind of connect everything in a nice way. Oh, and this actually brings me to a problem that you might encounter. So here you have an edge arriving, and here, right? So you can't just do this, because that produces n-gons because of this edge, right? If I were to join this up, and then I would tab it, you can see how this is actually it breaking, right? Not being able to calculate it properly. That's because of these points here. It's not merging properly. So you do need to undo join. You do need to be kind of careful with that. And the way I would solve it, and I know right now it seems like everything is a little bit chaotic, but I'm just trying to show you the thought process, right? How do you think when you are working with these tools? Because tools themselves are simple, right? We're almost done with the tools themselves, right? It's not a lot of them. It's the thought process. That's the hard part. So I need to kind of stitch this together properly. I could, in this case, honestly, I just could borrow these bottom polygons and just copy them up. That would probably be the smarter way to do it, but I'll show you the other way around. So if I just draw a line here, a line segment here, then I have a midpoint, right? And then I can, from that midpoint, I can draw a line segment to this vertex right here. Let me actually create a new layer just so that you can see better. I'll call it helper. Make it red, just for visual purposes, and there we go. So now you should see better. So I drew one line here and one line here, and now I have, I'll just kind of show you, I have the midpoint here that I can snap to, and I have this point here, right? And this is basically all I need now for SubD tools to create those faces that I'm after, you know, 1, 2, 3, and 4, and so on, right? So if I couldn't just copy existing polygons to the correct height, that's how I would be doing that, stitching everything together by using helper lines and helping snapping. But here, honestly, I can just kind of take these, holding down the Alt key, copy them upwards. It's going to, by the way, it's visually going to look weird when you're going to be doing that, but once you release the Alt key, it just works. So copying them upwards and then moving them to the correct position. Same thing here. I'll just do it as quick as possible. Same thing here. And same thing here. There we go. So this one goes down. This one goes down. And this one indeed goes down. So now the topology is correct. Now all I need to do is join everything up. Join, smooth. I still have some curves and some points left. I just delete them, hit tab, and now that's my shape. It's probably better if it's like that, flipped around, right? Maybe this is then moved down. Go ahead. Yeah. Mm-hmm. Well, the floor is technically it's technically flat to a certain extent. It's just the fillets here. Have you ever been to Barcelona? Antoni Gaudi's not Sagrada de Familia, but the apartments that Antoni Gaudi has made. Have you visited those? So he has these fillets, right? So this is kind of similar, right? The central part is usable while the filleted part is not, right? And you probably noticed that all of the furniture was in the middle of the room in those apartments. That's because you can't just kind of slap furniture to the walls anymore. But I think for a naturum, a nature center, that kind of functionality is unnecessary. To be able to slap furniture into the corners of the room. Technically to answer the question, I would probably select the floor. Let's see here. Wait. You lagged out, or I. Wait. Either I lagged out or you lagged out. Can you do the shuk again? Sharp and then go in. Are you wait? I will draw out the section and tell me if it, okay, like a bubble on the ground. So right now what we have is we have 3 maybe. We have something like this, right? This is our current section of the building, and what you want for it to do, draw it in the air with your finger. Wait, you're muted. Wait. yeah, I see it. Like that. Can you do it? Yeah, you can. But the question is then, how do I stop? the question is, so can you do something like this, and then it's gonna be a crappy one, like that, like an inverted one, right? Like that. The question is which part of the building eats up. So if this is the interior, which part of the building eats up that spike, right? So do you assume that you will still have a rectangle, something like this, you know, as your outer shell? That's the question number one, right? If yes, then the answer to as to how the answer as to how to create this is, let me really quickly draw out a box. Box that, sure, 10 by 10 by 10. Like that. Get rid of this just so that we can see better. I would probably insert edge here. Insert edge up somewhere here, right? Something like that. I would then select these faces. Well, let's simplify it. I don't want it to take too long. I would probably select these faces and extrude them inwards, right? Or wait, extrude won't work. Crap. Extrude won't work. So we need to actually manually do it. That's fine. Or we can kind of cheat a bit. Wait, I'm gonna cheat first. Why is this here? Technical difficulties, please hold. There we go. So this extrude SubD direction X. There we go, something like that, right? So now it's becoming that, you know, what you were talking about. If I were to look at it with a clipping plane, that, right? It is getting there, right? We have the belly and it's kind of going in and then becoming a floor. How do you make it more crisp? Well, you can always select these edges. Oh yeah, clipping plane. Clipping plane is obnoxious. Select, for instance, this edge right here, and you can crease it, right? And then take a look at it. So it becomes kind of locked in place. And you can also crease, for instance, well, let's see. Let's investigate. You can move this down, and then maybe we don't even need to crease it. No, we don't even need to crease it. Then it just straight up works. I'll delete that polygon. That polygon. Yeah. There we go. So basically that, right? The topology looks like this. Polygon, small polygon, angled polygon, polygon up. The question is what eats up this? You know, it's usually some interior panels that do this rather than the exterior shell that makes that effect, right? So it's not, well, it is part of architecture, but it's much more of an interior finish rather than architectural structure, if that makes sense. Right. That's a good example, you know, of good exercise of trying to figure out how to achieve a certain thing with a certain tool. Let's do one thing. Let's do one thing, and then we'll have a quick little break. I will show you a method or procedure that Rhino 7 enables, and it's basically converting a crappy mesh into a clean mesh, and then a clean mesh can be converted into a SubD geometry, which can be converted into NURBS polysurface geometry. So let me show you that. Here I have a 3D scan of an arm, and I'll just import it. And of course, you don't need to do it because you don't have a 3D scan of an arm. But any kind of a crappy mesh, well, this is not crappy, this is actually pretty good, but it's, as you can see, the polygon topology is a little bit all over the place, you know. It's a lot. First of all, it's a lot of polygons. If I select it and type in what, it's 144,000 faces, right? So it is a high density mesh. And we want to convert it to something that is not that high of a density, right? So one tool that Rhino 7 has is called quad remesh. So it remeshes the shape into quads, into rectangular polygons. And it's located under Mesh Tools, I believe. Yes, under Mesh Tools, right here, quad remesh. Or you can type it in. UAD quad remesh. So once you select this tool, it's going to ask you to select objects that you want to remesh. So I'll select the arm and hit enter. And then this menu will pop up, right? So here you can either specify a target edge length, or you can specify how many quads do you kind of expect to have, right? So by default it says 2000, and I won't argue with it. Let's try 2000. I don't know. Adaptive size, it's basically if your adaptive size is 0%, your polygons or quads that are being created will try to be as close to the same area. So all of them will want to have the same area. If your adaptive size is set to 100, then the area will change depending on what kind of curvature it has. It is a pretty complex like program that's running underneath this quad remesh. But this is adaptivity of the size of the polygons. Adaptive quad count, it's basically same thing. If it needs more than 2000 and this is turned on, then it is going to get more than 2000 quads. If it doesn't need more than 2000, then it's not gonna get that number. If this is turned off, it will never get more than 2000. Doesn't matter if it needs it or not. Use surface edges. Well, here it's a mesh, so it doesn't really work. But if you have a poly surface, like a fancy one, then use surface edges actually will work. Sorry, for tutorial or for pedagogical purposes, I do need to show you this. So we'll need to wait for the arm just a little bit. I will create a box. I will create a sphere. And I will kind of create or copy sphere here, Boolean union, and then Boolean difference. Delete. There we go. We have a super messed up shape, right? That cannot be converted into a mesh easily. If I select this and type in mesh, hit OK. This is a mesh topology that it creates. It tries its best to do quads, but you can see that everywhere where I made a Boolean, it kind of breaks apart, right? It's kind of messed up. So the mesh that is generated from this is crappy. But if I select this and do quad remesh, and I say, yeah, sure, 2000 quads, adaptive size, yeah. Here, use surface edges. Now I can choose this to be smart. I always use smart. It doesn't have any symmetry, so there's no symmetry axis. Detect hard edges. Yes, please. I turned it on. And preview, I also turn it on. So now it's doing the calculation. And now I hit OK. Move it to the side. And now this is a mesh that is generated with that quad remesher, right? So night and day difference between the two topologies here. Much, much cleaner. All of the edges are flowing along the direction. A much better form. So coming back to the arm, quad remesh. Well, right now it's grayed out, so because it's not a poly surface. Detect hard edges. I really don't care for this arm, but I'll just keep it on. I'll just click on preview, and it's going to do the calculation. So it's going to be a little bit slower, of course, because 144,000 polygons, right? Takes a while. But once it's done, you will see how much better the mesh is. Why am I showing you this? Well, first of all, it's a very good way of how to convert a mesh into a poly surface, into a NURBS poly surface, and reverse engineering meshes back into poly surfaces was a huge problem before. Right now, it's still not solved, but it's better, right? So it's finished calculating. I hit OK. Move it to the side, and this is the arm shape that I've got, right? That's the quad remesh. Let me go for Arctic view, right? That's the original, and that's the remeshed one. And this one is 3,234 faces, so it didn't really match the 2001. It kind of extended a little bit, but still pretty good. And this one is 144,000. So considering performance, this is like 40 times faster, right? Every time your computer lags, think if you can quad remesh some stuff, basically is what I'm saying. More interesting is that this can be now converted into SubD geometry. To SubD. Command is to SubD. Enter. It asks you a bunch of questions. I'm just looking at. No, everything's fine. You just keep defaults. Keep it set to defaults. You don't need to mess around with those. We just hit OK. Created one SubD. As you can see, it's immediate, right? Because it's so close. And now we have a mesh and a SubD representation of that mesh. If I hit tab, you can see that that SubD gets smoothed out, right? So now we have an arm 3D model that is perfectly smooth. If I look at it with an EMAP, right? That's a pretty good, a pretty decent model. But this is not where it ends. It ends with this becoming a NURBS polysurface, because let's say we want to do some Boolean operations on it, right? For a mesh, you can't do Boolean operations. Well, you can, but it's gonna mess it up quite badly. So if I select this and I type in to NURBS, that's a command, to NURBS, I hit enter. It's going to ask me for some options. Honestly, I don't really care at this stage, so I'm just going to agree to it immediately, and it's going to do the calculation. NURBS is heavy, so it takes a little bit of time to kind of convert it. There we go. It's done. And now this guy right here is our poly surface. So let me put everything in perspective. So we had a mesh, a very intense mesh. We converted into a quad mesh with quad remesh. We converted that into a SubD geometry. And we ended up converting SubD back into a NURBS poly surface. So all of these are surfaces now, right? And all of them are joined into a closed solid polysurface, meaning we can do Boolean operations on it, right? From the Rhino course, you remember that you can only do Boolean operations with closed polysurfaces. If it's open, right? If it's just if it has a hole in it, it won't work, right? So for instance, let me just draw a quick little box here, like that, and cut the finger off. Why not? Rotate a bit. There we go. I'll just make sure, yeah, that's intersecting. Boolean difference with this bad boy. Takes a while, of course. Delete. And now we have a clean cut, right? And this is also a closed polysurface. Arctic. You couldn't do this cleanly with a mesh. Yep. The quality, as in the quality of the small details. Well, to a certain extent, yes, it was high quality. For instance, here you have a fingernail, right? You kind of have an outline of a fingernail. If we look at it here, well, no, here, you are losing that bend, you know, for the fingernail. If I were to increase the resolution for the quad remesh, if I used more polygons, then the fingernail would pop out again, right? It would show up again. But in this case, I just wanted to show you guys the procedure fast. So I used a lower resolution thing. And usually for NURBS geometry, you don't care about micro details, such as, you know, in this case, it would be fingernails or veins in the arm. Let's actually... yes, it is. If you just use mesh command, we need to wait. If you just use the mesh command on the NURBS, that's the mesh that you get, right? Not the best, right? If you use quad remesh on the NURBS, then we need to wait for it to do the thing. But yes, of course, this quad remesh thing makes it so that meshes, NURBS polysurfaces, and SubD geometry can talk to each other and can be converted in between, right? Between each other. Let me just move this away. What? Did I delete it? Oh my God. Yeah, either way. Don't want to wait for it again. But yes, you can convert it back to a mesh in multiple different ways. One more thing that I want to check is if we do this and then I turn off mesh wires and I turn off surface edges and surface isocurves, now you should be able to really well, like, see quite well the difference in level of detail that you're missing. One thing to note is that you usually even for character design, I'm not even talking about architecture, but character design in itself, you don't want this level of detail to be embedded within the geometry. You want this level of detail to be embedded with texture and like bump maps and displacement maps and so on, but not within the actual vertices of the mesh, right? So honestly, I still think that this is better geometry than this, even though this looks higher detail. I would probably unwrap the normal map and kind of rebake it into a texture later on. But this is becoming off topic right now. I'll turn it all back on. Okay. Let's have, or sorry, are there any more questions? Nope. Okay. Let's have a small little break, 5 minutes, and then we will continue. Right. So the last one, recording, there we go. The last one, or last two tools that I want to kind of show you are the chamfer, or it's not called chamfer, it's called bevel. The bevel tool, and also edge slide tool. These two, slide edge and bevel. So what bevel does is, well, let me just create a box here. And actually, I will create a box that has XYZ count of 1. So it's a super duper simplistic box. There we go. Something like that. Smooths out into a sphere, right? Yada yada. Bevel. If I use bevel, it's going to ask me to give it edges, right? To select edges. So I'll just select this edge right here, just this single edge. And I will hit enter to bevel it. And now you can see that exactly what bevel does. It bevels the edge, right? It's kind of the same thing as chamfer, right? So we can kind of type in 5, I don't know, and have a bevel like that. One more thing, if I bevel this, there's 2 modes. One mode is absolute and the other one is proportional. So proportional mode is basically me describing in percentage or in proportion how far should the edge. So this bevel has 2 neighboring faces, right? The top one and the side one, right? And the larger it is, the more it eats away from the neighboring faces. So proportional offset mode, here I can type in what's the proportion of those faces that the bevel will eat. So I can say 0.5, right? 0.5 means it's going to go until the middle of those faces. One thing to note is if those faces are in different sizes, right? And I do the bevel here, and I do the same 0.5, it's going to find the one that is the least, like the lowest number, right? So it's this edge is not going to just move to the middle like so here. That's important to note. I almost never use proportional offset mode. I almost always use absolute because I like to work in units and to define my bevel in millimeters or meters or centimeters, whatever unit I'm using, right? So in this case, it's my box is basically a sugar cube, right? It's 1 by 1 by 1 centimeter or 10 by 10 by 10 millimeters. So if I do a bevel of 1 millimeter, it's gonna be like that, right? Also note that bevel locks, like it is a double edge, meaning that it locks the edge closer to its original position, right? Can you bevel 2 curves? Same time? Yes, you can. Does that? Can you bevel 3 curves at the same time? Yes. Does that? Right. Can you first bevel 2 curves and then bevel the third one? Yes, you can. You know, well, actually, yes, you can for this one, but for instance, for this curve right here, or for this edge, if I bevel it again, then this face right here becomes problematic, right? Bam, 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 and gone. So you do need to plan out parts which you bevel and why you're beveling them in the first place. Usually I use bevel to sharpen up the edges. For instance, I can select, let me do bevel, select all of the edges here, enter, and I'll just do 0.1. Super small bevel for the whole cube. If I tab it now, it is a cube, right? It's not a sphere anymore. So initially, by doing bevel on all of the edges, I kind of locked them in place. I can do one more thing, bevel. And I will select all of these edges here. And for segments, I will use 2 segments. Shit, crap. That's a little bit too much. Let's just type in 0.1. There we go. So now you can see that it becomes super sharp, right? And that's just because now I have not a single edge, but, oh, sorry, not a double edge, but a triple edge, which means that it holds even more, right? It does come at a cost, and that cost is weird stuff going on here, a little bit too sharp, right? And it usually happens because of this Zelda triangle right here, right? Too many triangles, not enough quads, makes the corners a little bit wonky, a little bit awkward. So keep that in mind. Honestly, what I prefer to do instead of beveling with 2 segments is just selecting all of the faces and using, well, let's first select all of the faces, make sure, yeah, there we go. Selecting all of the faces and using inset. Mode single, enter, same thing, 0.1. Enter. Tab. Huh? What the? Ah, yeah, okay. So it actually it does work on the edge, but we would still need to fix the corner, and the only way you can fix the corner is by beveling it, and yes, fair enough. So in that case, we do need to use bevel. Caught myself there. Put myself in a corner there. Right, what else? Oh yeah, edge slide. Edge slide is important. And that is the last thing that we're going to do. So I'm going to just delete this, or rather second to last thing that we're going to do. I'm going to delete one face. I'm going to take the box and turn it like that. Wait, is that open? No, that's not open. Where's the opening? There we go. So now 2 openings are looking at one another, and I'm going to just kind of position it like so. Maybe it's located like that. And I'm just going to double click on the opening here. Control Shift and double click. Control Shift and double click. Nope, not on that edge. Unselect, unselect, god damn it, unselect. Oh, I forgot that it does that. You are going to love this. Trying to unselect an edge. Just please, just. Okay, fair enough. I'll just do it again. So as you can probably see, selection in Rhino. God damn it. Okay. edge selection. The hell? Selection in Rhino is not ideal. Let's say it like that. Selection in Rhino could use a little bit of love, but it is what it is, and most of the time it works quite well. So just really quickly selecting all of these edges. Why can't I never select the bottom one? Please, just let me wireframe. Okay, what about this? Doesn't let me select that. That's cool. Can I do this? Yes, I can. That's cool. Bear with me. One edge left. There we go. And I think I have one extra one there. Yeah. Oh my God. Please, just. I'm going to cry. I think there's like a way of how to reselect things. Select, undo, undo. There we go. Please, just let me skip that. Let me. Okay. Okay. Literally struggling with the freaking edge selection. I will literally delete these two boxes, create two new ones, move them to here, rotate, delete those two faces. Really? And now you work? Okay. Loft, not loft, SubD loft. I don't know what happened there. Absolutely no idea. But now it works. And I'm happy that it just works. Okay, so now we have a banana, right? We did a banana, and what I wanted to show you is edge slide, right? Slide mesh edges. So if I were to, for instance, select this edge here, edge loop here, and I were to insert edge, I can kind of insert it anywhere I want. Oh, by the way, insert edge also has the offset mode, just like what we had with bevel. It also has the offset mode, which is set to absolute by default. But if I change this to proportional, you can see that now the edges will merge, not merge, but kind of tween between the right-hand side one and the left-hand side one, right? So it kind of follows the faces proportionately. If I do this with absolute, it's kind of always the same direction, right? So that's important. And let's just say I put down the edges here, right? So now I have them. And what I want is to actually move, just a banana. I just want to move these edges closer to this edge loop right here, right? So I want to move this edge loop, or maybe even not this edge loop, but just this edge closer to this edge loop right here. Well, I could do kind of this. I select it and I kind of try to move it closer like that. That's not good, right? That's kind of bad because I'm messing up the surface that I had, right? This was a, let's say that angle of a surface I want to keep, right? All I want to do is get this edge closer to here. That's where slide edge comes in handy, right? I slide it along the surface. So it's right here, slide mesh edges or vertices, or slide SubD edges or vertices. Select this bad boy, enter, and now I can slide it along these faces, right? without actually changing the faces themselves. Just it's right now it doesn't seem like it's useful. It is, trust me, it is useful. Close that. For topology, you will need it. With some tools, this will pop up. Selection filter will pop up, and it will ask you for things. What I like to do is close it and just keep closing it, because selection filter basically forces you to select things that are being filtered. So for instance, when I do slide, right, and I kind of try to slide the edges, the selection filter will only let me slide curves or edges, right? So it kind of forces me to select those. Once I'm done, it stays, and it means that I can then only select edges. I can't select the face anymore. So I have to close it to be able to select the face. Annoying, but it is what it is. Let's do something here. Inset single 0.5 maybe. That. Maybe these can go in. That. I don't know. Weird things. That's why you will. That's why I'm saying that you will have. You should at least have fun with the program. Kind of investigating what you can do and what you can achieve before you actually move into the site and try to actually solve the function, right? You first need to know what exactly is it that you kind of want to do and what's possible. I think I just broke it. Yeah. Yep. It's literally opposite of offset. So offset is you have a curve, right? And you offset it. Well, okay, fair enough. Offset also can go inwards. So this is offset, and this is what would be considered inset, right? They are developing a way of how to offset the edges to the surrounding polygons, but it's a much harder thing to do compared to just insetting the edges inwards into the polygons, right? Because when you offset the edges, you need to kind of work with all of the surrounding polygons of all of your selected polygons, and that's hard. But I saw in the patch notes that they are working on it. Yeah, so that's that. The cucumber, it's a weird thing. Yep. Mm-hmm. 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 How do they become 5-point surfaces? Wait, bevel. Yeah, so I'm now dealing with basically the top of a cube, right? So we have that, and then we bevel, and I'll just give it like 0.1. Oh yeah, if you only bevel one of the lines, yes. It let's go for this bad boy here. Bevel. like that, right? Then this is bad, right? It's this is acceptable still. Like having topology like this is not ideal, but it's okay. I would though try to fix it by deleting this face altogether and seeing how I can rebuild this with. I'm gonna get there. Just a second. how to rebuild this with SubD patches, so, or SubD single SubD faces, right? So could we do like a triangle and then a rectangle? It's much better if you have like something like this rather than an n-gon, because then you at least know exactly you know how this behaves, and this kind of sharp line, you know exactly where it's gonna go compared to this, right? This is like a pentagon, and this you at least can select this patch, right, and work with it. So yeah, also becomes much sharper apparently. So yeah, try to do triangles wherever you can, right? Wherever you see a pentagon. If you see a hexagon, by the way, then it's just two quads. It can be two rectangles that make up a hexagon. So that's easy to fix, right? It's uneven numbers that are hard, uneven corner point numbers that are hard to fix. We have here. Oh yeah, and even if you see something like this, right? Like super messed up geometry here, it doesn't necessarily mean that your smooth geometry is going to be messed up as well, right? Sometimes the flat geometry does intersect. Intersections are not that bad. Crappy topology is much worse. So now we have something like this. Still so bad, so bad. Anyway, more questions before we finish up? I will try to make this. For instance, here, right? I'm creating a pentagon, and I know that I'm creating a pentagon here. 1, 2, 3, 1, 2, right? Five points. But for this particular instance, I don't really care that I'm creating a pentagon, because it's going to, I know that I will not be working with this. I will not be grabbing it and trying to change like a part of it, right? So I will stick to it being a pentagon. It's very much, wherever you do n-gon, wherever you see that an n-gon is created, you don't need to necessarily immediately jump in and start fixing it, but you, in the back of your head, you have that, you know, oh yeah, that I need to kind of look at that area a little bit closer later down the line to see if it's still holding up, if it's still kind of working as expected. And if it doesn't, then the first thing that you do is you kind of start rebuilding the n-gons. One last thing that I want to do is actually put this like that, something like this, and I will actually rotate it like so. Or no, that's stupid. Let's not do that. I'll just position it like so, around the center point of the world, right? So I position it like so. And the last thing that I'm going to show you is reflect tool. So reflect tool works when I click on it. It asks me to select SubD object, so I select this. And it asks me to give it a reflection plane once I select the object. So my reflection planes can be either along the y-axis, which is green, along the x-axis, or along some other axis that I just kind of draw by myself. So in this case, I'm just, since we're close to world coordinates, I will use x-axis, but you can use your own line, you know, that you kind of just specify by clicking twice on the screen. Here I'm using x-axis. That, pick a point on the side to keep. So which part of the geometry, which side of the geometry would I like to keep? Well, I don't care. I'll keep this, like the left-hand side. Snap to reflection plane, always automatic. I prefer it to be automatic. Hit enter, and now nothing changes. You can see it's the same geometry. The only difference is that now half of my form is gray. And what that does, it basically, now if I select this edge right here, let's say, or let's do these two edges, and I move them out, like so, it will reflect on the other side, right? So it's like automatically reflecting to the other side whatever I do. So for stuff that is symmetrical, this is really, really good, right? If you don't want to do symmetrical stuff, then don't use this. Questions about reflect? Since you don't have questions, I'll just keep talking. The 2D, not the 2D, but there are some limitations to reflect, especially if you are adding geometry to your model, joining it with additional geometry. Reflected area might start messing up. That is fine. All you need to do then is use reflect again on the same geometry, and again you keep you just hit enter, and again you keep the same side, and it will kind of redo it. So if it's bugging out for you, just redo the reflect and it's gonna work. That's all I'm trying to say. We rotate it this way. That seems fine. I have no idea what this is, but it's starting to fly. Starting to fly. Okay. Oh, once you're done with the reflect, you can just, I believe, sorry. Once you're done with the reflection and you want to kind of break the symmetry, you can always kind of select the shape, type in reflect again, and click on remove existing reflect symmetry, and then you're back to, you know, your original shape, initial form. What the hell are you? Anyway. Okay, I will not be showing you anything about the site. We are done. No, we are done, of course. Of course you can. Yeah, it's straight up make 2D. For some reason now mine is, there we go. It's going. It is working, but you need to expect that you will get this, which is not ideal. Well, this is like a dashed line, right? So my line scale is a little bit off, a little bit messed up. I believe if I scale this up, if I scale this up, it's a little bit better. But still, you know, curvilinear stuff and generating line drawings from curvilinear stuff is always hard. What I like to do, I'll show you a trick. So let's say we have something like this, right? Then what I would do is I would create a new layer, just call it contours. Just with the landscape, I would create contours on my shape. Contour. Base point, doesn't matter. In the top view, I would just kind of contour it. Let's say from here along this direction every 1 millimeter, right? So it makes these bunch of sections for me, right? So I have that going on. And now when I do make 2D for all of this, now we wait, but eventually, there we go. When we do make 2D for all of this, it's going to give me a better, version, especially if I hide the hidden curves, but you can still see that there are a few mistakes that it makes, right? So you would need to kind of get in here and do the trimming and whatnot to clean it up. But just adding those lines, those contour lines, already helps it quite a bit to convey the curvature of the shape itself, right? So contour is your friend in this case. Ask yourself a question of how would you show a sphere in a two-dimensional drawing, right? And it's not so a sphere that doesn't look like a disk, right? In a two-dimensional drawing, you either do shading or you show with the lines, you show curvature of the sphere. So contour does exactly that. It just shows curvature. Here, my model is super bad. So, I mean, it's nothing interesting. So the contour looks really bad. But that's basically that. Does that answer the question? Yeah. Good. Honestly, I would probably do the contour on the from here to here, like that. And that would be like, you know, with the pencil drawing, you have the hatch. So I would just assume that that's a hatch. So I would use the thinnest possible hairline thickness and probably something gray, and would just kind of add it as a small little layer on top of my geometry. Yep. Oops. Don't do that. More questions? Go ahead. Go ahead. Mm-hmm. It's exactly the same. Let's see. Sweep, SubD sweep 1. Select rail. Yeah. Okay. So we need two edges here. Real quickly. Yeah. You go to here. If I have, let's say something. Oh. Just bear with me for a second. If I have sweep. There we go, a box. Yeah, I was looking for a box this whole time. And then we kind of delete this part, and or before we delete it, come on, just give me insert edge somewhere here. Now we delete both of these. And then I have something like that. I just want to test it out. I never tested it out this way. So sweep, right? We have one edge here, and there is like a weird like polyline here that's going to change direction. Let's see if that's going to work. Sweep 2. Select first rail. So let's see, that's our first rail. Select second rail. our second rail, and then cross-section curves. So this is where I'm not sure. If I, yeah, okay. Or maybe, what if we just do that? Yeah, enable. So for sweep to work, you actually need to do the polyline thing, right? You need these two curves to be joined up, so at least the cross-section curves are defined by a polyline rather than just us selecting the edges. So now again, if I do SubD sweep 2, first rail, second rail, cross-section, this time polyline or curve, and then this cross-section here, curve, enter. Yeah, everything here kind of by default values, it kind of works, it's okay. Ah, yes, would be a smart idea to join it up. Yeah, now it works. The only thing is that for some reason it makes a crease here, but to get rid of the crease, you just select it and you write remove crease. Yep, works. So sweep works exactly the way it worked in regularly in Rhino 6. I'm not sure. One thing that I'm not sure of is if sweep is gonna work if we have something like this, and then I do that, rebuild 3 or 4 segments. Okay. So you, sir, go like that. Oh. You, sir, go like that, and you, sir, will bulge to the opposite direction like that. I'm not sure if this is gonna work with sweep, with SubD sweep, but we can check. SubD sweep, 2 rails. First rail, second rail, cross-section curve, enter. Sure, okay. It tries its best. It tries its best, and I can kind of, can I show you why it fails? Yeah, that's I'm just wondering if the SubD sweep, if it doesn't let us show the low resolution, the flat shading of the tool. But yes, if you increase the amount of segments, wrong side, right? The more segments you have, the closer it is to actually working. And then, yeah, then once you're done, then it's going to show you the low polygon or flat shaded version. And then you can kind of start messing around with it, right? And starting to do, I don't know why, but I always show bridge or loft, doesn't matter. You know, with also more segments. And we have something like that, like I don't know. But yeah, sweep. I didn't even know. Well, I saw that it existed. I just thought that it's the regular sweep. Apparently, SubD sweep is a thing. That's nice. That's a really nice thing to have. Okay, more questions. While you're thinking, on Thursday we are going to work on the site a little bit. We're going to learn how to extract portions of the site and rebuild them as not necessarily SubD geometry, but just as regular surfaces. And then if you want to, you will be able to convert the regular surfaces into SubD geometry and really melt your building with the site. which might be a pretty cool approach as well, you know, Hobbit Town. Anyway, that is going to be on Thursday. And also we might, if we have time, we might go a little bit deeper into the SubD tools. But honestly, most of the stuff that I've shown you, it's enough to create most of the geometry, right? Last time I've shown you the car, and I can't find the car here, so I will not be showing to you this time. I just thought that maybe if I showed you the car now, you would kind of recognize, you know, same procedures or same design movements that I was talking about right now or today. Anyway, that's it. Yes. To this one? Well, this one right now is a solid piece of like concrete, let's say, right? Because it doesn't have any openings. So as long as it doesn't have any openings, no. It's actually a much harder thing to explain. There is a mathematical problem of what's called the tennis ball problem, right? In mathematics and computer graphics. And the way that problem is kind of described, I'm going to butcher it, but I'll try to describe it. You have a ball, right? So any program understands that this is like inside and this is outside, right? It's easy as long as the ball is closed, right? Once you give it thickness, then the program gets confused because suddenly, okay, so this is still outside, that's easy, but then this is inside, but then this is inside for this mesh right here, right? So suddenly it doesn't understand that there is thickness because there's no connection between these meshes, right? So the question is then, how do you make this geometry connect? And that is, I think that's why it's called the tennis ball problem, is because the solution to it is to have a seam, right? And make it into this kind of a ring. Well, in the section, it's a ring. In 3D, it's something else. But to make it into this kind of ring where the geometry folds into itself, right? And becomes enclosed, right? And then suddenly the program understands that this is empty, this is empty, this is filled, right? Same thing here. If I were to just take this and create an offset of it, the program would understand my geometry, since this is closed, as two separate geometries, right? One smaller, one bigger, and the smaller geometry is in the bigger. But if I were to say, this is open now, and I do the same thing. Let me cell CRV delete. And now if I select it and do SubD offset, I don't remember SubD tools. Of course, it's offset SubD and not SubD offset. So if I do offset SubD and select this, enter, and I give it, I have no idea, like 1 for distance, then it kind of, well, right now I have like two versions of it, the thick boy and the thin boy. So the thick boy, since I gave it so much thickness, it kind of is breaking into itself, but it is being thickened. And if I type in what, I can see that that's a lot of different unnecessary things. God damn it. Just tell me if it's closed or not. Okay. To NURBS. There we go. This one. What? Closed solid polysurface, right? So clean solid polysurface, and this is like a thickened boy. So that's offset SubD. Looks so. I mean, sure, I guess. Wait, I want to see the inside of it. Clipping plane. Time for some clipping plane action. My God. I mean, hey, it works, right? We started with a banana, we ended up with this monstrosity. Just finish up with a pretty picture. Oh yeah, and since I have the NURBS polysurface version of it here, you can't really tell probably, but it is lagging for me quite a bit. This reflective like EMAP is lagging for me because NURBS polysurface is super heavy. So usually I have it as a final. I export it as polysurface as my final step in the design process, just to kind of speed things up, and I try to stay in this kind of modeling for as long as I can. Yeah, looks fine. More questions? Yep. Yep. Oh yeah, absolutely. I started using V-Ray in Rhino 7 ever since I said that. I was just lazy. That's about it. I was just being lazy. Oh, I messed up there. You press the render button, right? Then it kind of calculates, and then it's. Yeah, you just make it into concrete. Oh, you mean mapping? The polygon. That's a good question. That's a good question. The mapping techniques usually for these kind of surfaces are harder to do than for boxes because you can't use box mapping. So instead, there are two ways of how to go about it. One way is to still use the box map and don't care. That's the way I go about it. The other one is I lagged. Okay. One way is to do box mapping, and just don't care about it. Yes, the textures are going to be distorted, wherever it kind of bends, but it is what it is, right? Another way is to do unwrap, UV unwraps, which is a much harder one, and I don't encourage you doing it right now. But it's basically when you have your form selected and you go to texture mapping, there is this UV editor slot here. And also there should be like, where is it? Delete mapping, OCS mapping, cylindrical. Yeah, there we go, the unwrap. So what unwrap does, it basically tries to unfold all of your geometry and lay it out flat on the screen, and then you export it into Photoshop, for instance. You slap on your texture on it, and you import it back, and then you have it as a texture purposely made for that particular geometry. It's used for video games, it's used for movies, wherever they know that the asset will not, or model will not change anymore, right? In our case, very risky business, right? Because you spend like 2 hours, 3 hours doing the map for your model, and then you go into one of the meetings with us, and we go, yeah, door 5 meters to the right, and suddenly all of your mapping is gone, and you need to spend time redoing it. So I really don't think you need to. Honestly, I have been doing unwrapping 5% of the time. like 5% of my projects have geometry that is unwrapped. 95% just have straight up box mapped geometries. And if I need to, I kind of Photoshop out some weird stuff. It's all about how you position the camera. Actually, I'm kind of interested to see, and also, what the hell is this? Why is this? Ah, that's the inside. My bad. Wait, undo. There we go. I'm very interested to see one thing, and this is what we're gonna do last. If I do indeed use some sort of concrete texture, I want to see how it's gonna look like on this model. No, stone? No, concrete. CCC, concrete. Of course. Of course, library updates. Come on, please, please. I'm trying to run a webinar here. Please work. Ah, there we go. Yeah, this is tiley, very, very tiley. So I will grab it, drag it in here. Apparently I dragged it twice, doesn't matter. Apply it. I mean, it's not that bad. So this is not box mapping, right? Keep in mind that this is without the box map. This is just the geometry, the concrete being mapped on the geometry. So if you like the way it tiles right now, you can keep it. The only thing that you will need to be mindful of is this, that you can't do the box map, meaning that XYZ size, this doesn't matter anymore. What matters is how many times you repeat your texture. So here I can say I want to repeat it 10 times. And it doesn't work. Shit. Why doesn't it work? Wait, that's weird. That is super weird. 111. Technical difficulties, please hold. I mean, yeah, okay, so it's displaying weird, but it's rendering correctly, the way I want it to, right? So if I were to zoom in here, I'm probably lagging right now, so sorry about that, but you can see the tiling is kind of following now, not perfectly, but it is following the curvature, right? And I think that is that's kind of enough, right? For these kind of projects, it's much more about the geometry, much less about the tiling. Let me just kind of mess around with the exposure so that you can see better. There we go. And let me stop the render just so that it's destroying my computer. Note to self, can't do a webinar about V-Ray. That's not gonna work. I just can see my my webcam giving me like 2-3 frames per second. A slideshow. Get them in a slideshow. Honestly, like the curves look quite nice with the concrete. Like that pocket right there looks quite good. Right. More questions? Plop. You can always make a turntable. Make it turn for you. It's always nice. You can make it turn real fast. I don't know. I don't have anything else to say. We're done with the tutorials for today. Test out the tools by yourselves. Mess around. Do an airplane, I don't care. Do something fun. I do care that it needs to be fun. And we will continue on Thursday, and Wednesday is the helpless day. Okay. Cool. I'll stop now.